guys, these are your notes for the week of April 27th. We're going to be talking about monopolies, oligopolies, monopolistically competitive markets, as well as the factor market. Here is your monopoly graph. Notice that it has a downward sloping demand curve and a downward sloping MR curve. MR, Mr. DARP, has been separated. MR is separated from this. It is an inefficient market because they are going to be producing less quantity in order to get more revenue compared to a perfectly competitive market. Characteristics, it's going to be one firm only in a monopoly. It is very difficult to enter the market, so it's high barriers to entry. They have a differentiated product for a monopoly. And remember, you still are going to produce to profit maximize at MR equals MC, but for this one, you're going to go all the way up to the demand curve, wherever that point is, and over, and that is going to be the price. Take a look at the producer surplus. Normally on the graph, if they give this to you, they'll have the MC curve being a straight line, so that way you can calculate the producer surplus easier. But producer surplus is below the price and above the MC curve, which is also the supply curve. And then you see the consumer surplus is above your price. It should normally be a triangle. And then you have deadweight loss. The reason why you have deadweight loss is because we are inefficiently producing. In a perfectly competitive market, you'd produce where supply equals demand, and your MC curve is your supply curve. So this is the point that in a perfectly competitive market you would produce at, where your MC and your demand hit. These have a couple different names, and I'll go ahead and write those down. So that point here that I went ahead and showed you is the perfectly competitive point, the socially optimal point, the allocative efficient point, and the price discriminating point. We're first going to talk about the perfectly competitive, socially optimal. You don't want to just go ahead and hit the point. In order to find the quantity, you're going to go to your all the way down. So that is the perfectly competitive point, quantity, and the price that a firm would charge if you were operating here on a monopoly graph. Socially optimal, that's where society wants you to produce, and it's using your resources allocatively efficient. Also, if you're a price discriminating monopoly, you also will produce at this price and this quantity, Price discriminating, though, does not actually charge this price. How price discriminating works is they charge every single consumer what they're willing to pay. So, for example, their total revenue, I'm going to go ahead and shade in total revenue for you for a price discriminating monopoly. Here is the total revenue for a price discriminating monopoly, because remember, they're not charging one specific price. They're charging everyone what they're willing to spend. So the total revenue, price times quantity, is going to be that entire trapezoid right there, and the quantity they're going to produce at is at Q1. Now we're going to take a look at monopoly and a total revenue graph and how that is determined. Now remember, total revenue is maximized where MR equals 0, and that's really important to know for this concept. So where MR equals 0 is where total revenue is maximized. When you go all the way up, that is known as the unit elastic point. Anything to the left of it, so this point right here, this is the elastic portion of the demand curve, meaning elephants under the influence. Anything to the right of that point is going to be inelastic. And it just shows the relationship between total revenue. So for elastic, when price goes up, total revenue goes down. And price goes down, total revenue goes up. For the inelastic portion of the demand curve, when price goes up, total revenue goes up. So I'm going to ask you to go ahead and pause the video and take a look. I did the best I can for your doots to make them as even as possible. I had to add your ATC in there. So here's a couple questions. So go ahead and pause the video. The first question says, if they're trying to maximize profit, what is the price? The second one is when output is 8, what is the profit per unit? And if they are allocative efficient, what quantity and price would they produce at? And then between 16 and 18, what is the elasticity? So is it elastic, unit elastic, or inelastic? All right, so here are your answers. The maximum profit price, so you want to find where MC equals MR first. You're going to go all the way down and then all the way up to notice that your price will be right here at 24. When output is 8, what is the profit per unit? So if the output is 8, which is right down here, you got to find out what your total cost, which is right there at 18. And then what is your price? That's 24. So your profit would be this area right here. 24 minus 18. And it's going to be $6. If they want a total profit, you'd have to multiply the $6 times the quantity, which is 8. Allocative efficient is where MC equals D, so the price is 20 and the quantity is the 10. Between 16 and 18, remember, elasticity is determined by the MR, wherever MR is 0. So right there, if you go up, that's the point. That's the unit elastic point. So this is elastic. Anything to this side is inelastic. So between 16 and 18, which is right here, is the inelastic portion. We can regulate a monopoly. Remember, unregulated is where MC equals MR, and then you go all the way up. But if the government wants to put a regulation in, they'd operate at the socially optimal point where MC equals D. You can also do the fair return price, which is ATC equals D. So the problem with the socially optimal is that the monopolist will lose money. So the government may want to subsidize. So that could do like a per unit subsidy where the MC shifts, or a lump sum where the ATC shifts, to also change that. We have natural monopolies out there like TECO because of the high cost of barriers to entry in there. So the next portion is the oligopoly. They have few firms that control major shares of the market. It's very difficult to enter, and they have differentiated products. The key words that you want to associate with oligopoly are interdependence, because they depend on each other to determine what the prices are. And we'll see that into our matrix here in a second. They can collude. If they collude, that means they work together to maximize joint profit. And you see the game theory advantage where they basically analyze the strategies dealing with situations where we depend on each other. So for an oligopoly, you're going to be giving a payoff matrix here. This shows you the profit. So we have two different groups. We have B mine and G mine, and they can decide to cheat or not cheat. And they, when we look at oligopolies, we just compare two of the firms. First thing you're going to want to do is to make sure you understand which numbers mean for what company. So G mine, I'm going to outline in purple. G mine's number are the first set. So the first set of numbers are G mine. You're going to do your stars, the up and down, and then side to side. So I'm comparing the numbers up and down for the first row. That's 10 or 5. 10 is higher than 5. For the second set of numbers, 25 or 20. 25 is higher. So up and down for the first set of numbers, and then the second set of numbers you're going to do side to side. Do you want 5 or 20? You'd rather have 20. 15 or 25, you'd rather have 25. The Nash equilibrium is where the two stars are together. So that is the Nash equilibrium. That is what each of the companies will decide. Now how you read this is B mine, these are cheats and not cheat. And you read B mine horizontally. So since we have the 25 right here, star, that's B mine's numbers, they are going to cheat because it's in this row. If you're looking at G mine is going to be looking at the numbers vertically, so up and down. Their $20 is right here, so you are going to see that they are going to not cheat. Another thing you could be asked is if they have a dominant strategy. Dominant strategy means they do the same thing no matter what the others are going to do. Take a look. Does B mine or G mine have a dominant strategy? Pause the video. In this example, they actually both have a dominant strategy. No matter what, B mine is always going to cheat. For example, there's the star there, they're going to cheat there, and they're also going to cheat there. G mine is actually also going to always never cheat. It's just better off for them. So for example, G mine is right here, so they are not cheating. Their other star is right here. They are also going to not cheat. So how you read these is B mine is horizontal, G mine is vertical. You could also be asked if they are going to collude together. Collude means work together, not looking at the matrix on here, to maximize joint profit. In order to maximize joint profit, you'd find the square that they have the most combined profit. In this example, you wouldn't have a maximized joint profit on there because you see 25 and 20 and 20 and 25 are in the same categories, so they wouldn't actually have a one where they would collude to maximize joint profit. But how you would do that is just add the numbers together in the boxes and find out which box has the highest number of profit if they colluded. The next market structure we're going to talk about is a monopolistically competitive. That is in between a perfectly competitive and a monopoly. They have many firms, few barriers to entry, just like a perfectly competitive markets, but they do have a differentiated product that's more like a monopoly, and they do have some control over price. The graph for a monopolistically competitive market is the same as a monopoly. Usually the demand is going to be more elastic, meaning more flat, because they won't have as high of a price as a monopoly, but you can still draw it the same way. The big thing about this is in the long run, they have zero economic profits. They have normal profit, just like the perfectly competitive market. You would draw your ATC, go down, 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 hit your price, continue going down, 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 hit MC, and then go back up. And that shows you zero economic profit in the long run. So that is a monopolistically competitive market. They still go ahead and operate. They produce where MC equals MR, and then they go all the way up to the demand curve to find the price. Last thing we're going to look at today is the factor market, or the resource market, labor market, same thing. Here you produce where MRP equals MRC, and MRP stands for marginal revenue product, and then the MRC stands for marginal resource cost. We're going to look at a perfectly competitive market, labor market here first. Here's our graph for a factor market, and remember, we're hiring workers in this. We're not actually producing a product, we're hiring workers. You'll notice the wage is going to be on the axis and the quantity of labor. They are also wage takers in this labor market. Notice that there's a little bit difference though. Instead of Mr. Darp, we have Santa equals Mr. Claus. Your supply curve is same as your MRC, which is your wage. Downward sloping demand curve, demand equals MRP. Don't make Rudolph P. MRP is going to be the marginal revenue product. You produce for your MRC equals your MRP. You keep hiring workers as long as your MRP is greater than your MRC. Again, you want it to be equal, but remember, you don't want your marginal resource cost to be greater than your marginal revenue product. So always keep on hiring until your marginal resource costs get higher. We're going to take a look at a chart for practice. We've done one of these in the past. We're looking at Sparkle Car Wash, and I have the number of workers in the column, and I also have the amount of cars washed. First question I'm going to ask is the marginal product. Where is that maximized? Well, first off, in order to find marginal product, you have to find the change in the amount of product they produce. So I'm going to go ahead and give you that chart here. So when I go ahead and find the change from each additional worker, I'm going to see the product is maximized right here at the 25, so that's going to be 3. 3 workers is where my marginal product is maximized. You're going to notice that you're going to see that the marginal product is going to start declining after the third worker to 15, 10, and 5. The reason why this is happening is because of diminishing marginal returns. After a certain much, the workers kind of get in the way. The next question is, if they Sparkle charges $6 for a car wash, what is the maximum daily wage that they're willing to pay their workers? Let's go ahead and say specifically their 4th worker. So what would the max be if they decided to hire 4 workers? What is the max wage that they would pay them? Well, if you notice that the 4th worker brings in 15 cars, so the max that they'd be willing to pay them is 15 times how much they're actually getting in total revenue, which would be $90. They definitely wouldn't want to pay them $90 because they wouldn't be making any profit off of that, but that would be the max that they'd be willing to give that worker for their wage, since they only bring in that additional 15 cars. Here's a formula that you should be familiar about. It's the marginal product of labor over the price of labor should equal the marginal product of capital, K is for capital, over the price of capital. For example, this is the formula. You want it to be equal to maximize, but for example, if your capital, if you go ahead and divide that, so say for example your marginal product of labor is 10, your price of capital is 2, and that gives you 5. Okay. And then your capital, it cost you $100, but the price of the capital is, let's say, $10. 100 divided by 10 equals 10. So you see that the marginal product of capital over the price of capital is 10 is greater than 5. You'd rather produce more machines and less laborers in that stance because the marginal price of the capital or the marginal product of the capital over the price of the capital is greater than the labor. All right, I hope you guys got some information out of this video. Go ahead and, for extra practice, AC/DC economics. So, for example, if you're confused about oligopolies and you want a little bit more of clarification, go on AC/DC economics on YouTube and put in oligopoly or payoff matrix, and you'll be able to see some videos that are more intense and more detailed into that topic. Same, for example, if you need information on the factor market, go ahead, AC/DC economics. Or you can go ahead and look at the Khan Academy. So they have different topics for micro as macro, and they have videos, and they give you practice quizzes at the end in case you're a little bit confused to see if you do understand the concepts. All right, talk to you later. Bye.